Welcome students. In this lecture, we are going to learn some basic concepts about modulation and what are the needs for modulation. First, let us see what is modulation. See, in a communication system, the three basic components that we know is there will be a transmitter, a receiver at the other end, and in between transmitter and receiver, there is going to be a channel. And whenever we transmit signal from a transmitter to a receiver, as the signal passes through the communication channel, it gets affected by noise. If suppose, let us assume that we are transmitting some voice signal. Usually, the range of voice signal will be from 300 Hertz to 3 kilohertz, which means this voice frequency or audio frequency, voice signal frequency is very less. It's in the range from 300 Hertz to 3 kilohertz. Now, if we are transmitting such a low frequency signal to a long distance, as we said, as it passes through the communication channel, definitely it is going to get affected easily by noise, and the signal that is received by the transmitter will be completely disturbed. We cannot get the signal that we actually transmitted at the receiver side. The reason for this is this voice signal is of low frequency. Okay. Now, if we want to transmit the same low frequency signal to a long distance, then we have to go for this process called modulation. Where in modulation, there will be two inputs given. One is called as the information signal, or you can say it as modulating signal, or the other name is also called as baseband signal. So this baseband signal will be a low frequency signal, and this low frequency signal cannot be transmitted to a long distance. For that purpose, we are making use of another signal which is called carrier signal, and this carrier signal is of high frequency. It will be usually a high frequency signal. Now, the purpose of this carrier signal is to carry our low frequency information to a long distance. That is why it is named as carrier. It is going to carry our low frequency message over it, and this information gets ridden over the carrier signal till it reaches the destination. So the two basic input signals required for performing modulation is information or the message signal, and the second input is carrier signal. The basic difference between message and carrier is message is of low frequency, carrier is of high frequency. Now, moving on to the definition of modulation. How, as I told, this carrier signal is going to carry the message, or in putting in the other way, what we can say is the message signal rides over the carrier. Now, how this message is riding over the carrier, or how this message signal can be superimposed on the carrier is by changing some properties of the carrier according to the instantaneous value of the modulating signal. So what we are going to do in modulation is we are going to change some properties of carrier signal, and these properties can be either its amplitude or frequency or phase. So any of these three properties of the carrier, high frequency carrier, will be changed according to the instantaneous value of the modulating signal. So this is our information. This modulating signal is going to have the information that we have to transmit to a long distance. Okay. Now, according to the instantaneous changes in the modulating signal, we have to change either the amplitude of the carrier or the frequency of the carrier or the phase of the carrier. So this is the basic definition for modulation. So some properties of carrier will be changed according to the instantaneous value of the message. And the device that performs this process of modulation is called as modulator. So to this modulator, we will be applying the message as well as the carrier. The purpose of the function of this modulator is to change some properties of the carrier according to the instantaneous value of the message so that it can be transmitted over a long distance. And this is how we can represent carrier and the message signal graphically. If you look into this, the message signal is a low frequency wave. As we know, message is a low frequency wave. So we can draw with less number of cycles per second. And the carrier signal is a high frequency wave. So there will be more number of cycles per second. This is the graphical representation of carrier and message or modulating signal. Now what we are going to do in modulation, we are going to change some properties of carrier. So the carrier's property will be changed according to the instantaneous value of the message. So according to the variations in the message, this property of the carrier is going to get changed. By this way, we are superimposing the message on the carrier. Let's explain this with the help of this picture. Now, let us take an example that we are throwing a feather from one point to the other. Now, as we throw the feather, will it reach a long distance? Definitely not. Is it? Because it's a very light. It's of very light, less weight. So, when we throw a feather in air, definitely it will fall down immediately and it cannot reach a long distance. Now, let's take another example. The same feather, if we wrap it in a paper, here the same feather is wrapped inside a paper, and this feather is now, after wrapping it inside a paper, we are throwing it from one point to the other. Now definitely we can say that before wrapping the feather on a paper, it will not reach a long distance because of its less weight. But once the feather is wrapped inside a paper, now it is thrown from one point, it can reach a long distance. So this is a very simple analogy for explaining this modulation. Is it clear? So this is the message. The feather is the message. This message or feather is of lightweight. That is, we can say this is lightweight, so it cannot travel a long distance as our message, because our message is low frequency. Okay, but once the feather is wrapped inside a paper, it can reach a long distance and it is becoming a high frequency signal. So this paper that is wrapping the feather becomes the carrier. So here we can say the feather is nothing but message and paper is nothing but carrier. So this is a very simple example for explaining this modulation concept. Moving forward, let's go into the need for modulation. Why this modulation is necessary? Okay. The very basic need is it is going to reduce the height of the antenna that is required. Let us assume that we are transmitting a message signal of frequency 3 kilohertz. Okay. The height of the antenna that is required to receive any signal is given by height h is equal to lambda by 4, quarter wavelength, where lambda is equal to c by f. Now in this example, let us first calculate lambda. C is nothing but velocity of light, which is 3 into 10 power 8 divided by f. We have taken it as 3 kilohertz, so which is 3 into 10 power 3. Lambda becomes 10 power 5 meter, or we can say 100 kilometer. This is the value for lambda. Now for this lambda, if I calculate the height of the antenna, we can say this is 100 by 4, which becomes 25 kilometer. 25 kilometer. This is for a low frequency message signal. Now let us assume that we are increasing the frequency of the signal. So let's take a carrier frequency. As we do in modulation, we are increasing the frequency of the signal. Let's take the frequency to be 1 gigahertz. Now for this 1 gigahertz, lambda becomes 3 into 10 power 8 divided by 1 into 10 power 9, which becomes 0.3 meter. Now for this, the height of the antenna is going to be lambda by 4, which is 0.3 divided by 4. We can say this to be 0.075 meter, or it is 7.5 meter. So as we can see, whenever the frequency is less, the height that is required is 25 kilometer. Okay. If we increase the frequency of the transmitted signal, when we take the frequency to be 1 gigahertz, the height of the antenna is very much reduced. So this modulation, it will reduce the height of the required, that is height of the antenna that is required, because 25 installing a antenna of 25 kilometer height is highly impossible, and this can be reduced if we increase the frequency to some higher value. This is an example for that. The next important need for modulation is effective radiated power. That is this modulation. Whenever we perform modulation, whenever we increase the frequency of the signal by superimposing the message over the high frequency carrier, the power that is radiated is highly increased. The reason is the radiated power is always directly proportional to 1 by lambda square. Okay. Now, as in the previous example, what we have seen, when lambda is equal to, when frequency is 3 kilohertz, lambda is 100, right? And frequency, whenever it is 1 gigahertz, lambda, we have got it as 0.3 meter. So as frequency increases, whenever the frequency increase, lambda is getting reduced. When lambda gets reduced, according to this relation, we can say that the effective radiated power becomes more. So this power is increased. So this modulation is going to increase the effective radiated power. The third important need for modulation is it avoids mixing of signals. Now let us assume that in a room, 3 persons are talking simultaneously through a single person. Now in this case, definitely this person is not going to hear anything out from any of these people, because all are talking simultaneously. So no information will be received by this person. The same way, let us assume that there are 5 users, and all 5 users are transmitting through the same communication channel. Now, since the voice frequency is very less, the range of frequency is going to be very less, from 300 hertz to 3 kilohertz. These n number of persons are going to speak with the same frequency, almost similar frequency, with the same range. So since all these frequencies are going to travel through the same communication channel, it gets mixed up with each other. There will be some interference. It will be mixed up. Okay. And it cannot be retrieved or extracted at the receiver side. Now, if we employ, that is, if we use modulation here, what we can do is, we can modulate the first person's speech with some frequency F1. Likewise, second person's speech with some different frequency F2. Third person's speech can be modulated with frequency, carrier frequency F4 and F5 similarly. Now, since each person's speech is modulated with a different carrier frequency which are far away from each other, in this case, after modulation, though all these 5 signals passes through the same communication channel, there won't be any mixing of signals because each and every signal is getting modulated with a different carrier frequency. So in this case, we can say that without any mixing, it will reach the destination. So whenever we use modulation, we can avoid interference. We can avoid mixing of signals because each signal can be modulated with a different carrier frequency. Now, next need is it increases the range of communication. This is the basic need for modulation. As we told, whenever a feather is falling down, definitely it will not reach a long distance because it is of less weight. The same way, whenever it is wrapped inside a paper and we throw it, we can make the feather to reach a longer distance. So, whenever the message signal is superimposed on the carrier, so when we perform modulation, we can make the message signal to travel a long distance. So this modulation is going to increase the range of communication. The next important need is multiplexing. Multiplexing is explained in the previous slide itself, right? So this is called frequency division multiplexing. This is an example for frequency division multiplexing. Many signals are getting transmitted through the same communication channel at a time without any mixing. This is called multiplexing. The last important need for modulation is it improves the quality of reception. What do you mean by that? See, this without modulation, whenever the signal is passing through a communication channel, it gets affected by noise because the signal is going to be of very less frequency. Now, after modulation, since the carrier is going to carry the message and this carrier is of very high frequency, it will not be much affected by noise. So, at the receiver side, the signal can be reached without any loss in its quality. So this modulation is going to improve the quality of reception. These are the basic needs for modulation. First is reduction in height of antenna. It also increases the power that is radiated, avoids mixing of signals. It will increase the range of communication. It allows multiplexing. At the same time, it will improve the quality of reception.